Hello everyone, my name is Noble Paul and I'm part of Team 3 in the Master Project in the FSE 100 class, and this is our Master Project submission. This is the compilation of our three games, and the collection is called Video-Physiotherapy. Uh, my team consists of myself, then Tran, Ali, and Goshen Raj. So in this presentation, we'll be going over what the project is, and then we'll go over the technology we've utilized in this project to develop all these games, and then we'll go over the games themselves. We have three games, and then we'll discuss what the results, the output we gathered from developing these games, the pros and cons we found while developing and are still found in some of the games, and the future improvements we can make to this game. And then finally, we will be going to the conclusion. Introduction. So in this project, we decided to make a computer application, a web-based computer application that's mainly used by physiotherapy patients as a supplement to aid in their physiotherapy. It'll help them to regain their fine motor skills, and that was the main focus of this project. The technologies we've used for the web-based web browser, wherein we coded our games, B5JS, where we coded the games in JavaScript, and Teachable Machine was the lightweight AI model we used to train the AI, which we used in our third and final game. This is the overview of our main menu. At first we wanted to go with a space-based Star Wars-esque theme, but we found it hard to implement the theme, as we found it sort of clashed with some of our games. So we decided to go with a black and white aesthetic as we found it quite pleasing and it did the job. This black and white theme carries on all over the three games as well. We have our three games here. The first one is the Aim Trainer, the second one is Catch 'em, and the third one is Find the Treasure. It's the overview of game one. The first game is Aim Trainer. We used tabs as the main form of human-computer interaction. Like the types of feedback we obtained from this game are audio and visual. Our main source of inspiration were Aim Trainer games like OSO, uh, which uh, which requires you to have both hand-eye coordination and have fast reflexes. So we decided it would test both our patients or users' reflexes as well as improve their fine motor skills with their wrists. Tapping can be a very helpful way of developing fine motor skills in your wrists. For the feedback in this game, the audio feedback in this game, it'll provide a nice ping sound when you correctly tap on the target. But if you tap on the blank space, there will be no sound. For the visual feedback, once you correctly tap on the target, it'll update the score counter and increase the tally by 1. So here's the demo of our first game, Aim Trainer. As you can see, if you tap on the targets correctly, the scores get updated, but if you miss, the scores remain constant. You can quit anytime by clicking on the central quit button and return to the main menu to choose which games you want to play. Now we're going over to the overview of Game 2. Game 2 is called Catch 'em, and it uses both hand-eye coordination and reflexes to test the user's capabilities. The type of feedback we use in this game is only visual feedback, because we found it that if we included audio feedback, it was kind of all of the audio comes out simultaneously and produces a chaotic noise. Um, The main inspiration for this game was the famous retro game Atari Breakout, where instead of reflecting back the ball, we thought we could do a spin on the classic game and use the shield against the targets that are incoming and absorb them. Uh, the main mission of this game is that four objects will appear randomly on screen with varying speeds. You have to reflexively catch all four of them. You'll have up to 20 lives. Once you lose all 20, you will lose your scores and will be led back to the main screen. This is the demo of the Akachan game. As you can see, four objects appear randomly on screen and move with varying speeds. You have to use your reflexes to fastly and correctly capture all three targets before they breach your defense and make you lose your lives.
Okay, thank you, Nobel, for his presentation. And now it's my turn to present the rest of the slides. The first slide, the first game is that the final game is game three. Game three is basically an AI integrated game. It will integrate the AI learning model to classify our poses. It's like a multi-label classification problem where we can have the pose, various pose to we have to do those poses in order to control our our target to the object. The target is the treasure. Our human computer interaction here it by doing body poses. By doing that, we are trying to help the patient in order to be more active, be more um, develop more thinking and then more interaction with the body in order to to win this game. Uh, the type of feedback is visual. So by visual, we mean that um, the player can see where the object going and then to try to find out to do like make another poses to try to drive the target into the right place is the treasure. Okay, so for this game, I train this learning machine learning model. I think this deep learning model in teachable machine is a really great service, Google services that help us to learn more about AI and machine learning. So I train this with five classes. It's up, down, left, right, and do nothing. So here's our post and our result of these posts. As, as you can see, the result is quite accurate. This is a really quick demonstration about our video games, the game Treasure Hunt. As you can see, it's really easy to mess up because once you have like do the wrong pose, it's really hard to get control back into this thing. And furthermore, we have to add a lot of data into this because sometimes this can be like overfitting. This model can be overfitting, and then like the nothing class, if we have a lot too much uh, like doing nothing class, it will really likely to be overfitting, and then this model will not work exactly as we want in real life. So I will show you a final result, the entire game that we tie anything, we merge anything together in one game. So here's a video game. As you can see, this is our menu, and we try to maximize. We are trying to add a lot of randomness into this thing, into this menu, in order to make that we try a lot to make our artistic aspect of the game really works better. So there are three games. Let's try with the first game, I'm Trainer. So every there will be a really nice clicking sound whenever you got a right object. and then the time will shorten after each round of for clicking mouse. And then as you can see, the targets appear like really randomly, right? Really randomly with like a random color, random size. Let's quit this game and let's continue to our next game is catch 'em. So with this catch 'em thing, we have to use the left and right keyboard, the keyboard on our screen and on our keyboard to control the slider. And then our mission is to catch all the balls without any um, without any uh, like missing any balls. We in this problem we have to keep track a lot of object like four objects at a time, and then try to get as much as possible. So the replay button and the quit button is really working. So let's go to our AI game, Treasure Hunt. So for this Treasure Hunt, we will hover to begin. Yes, the camera sometimes take longer to render. So yeah, so this we can control this object, and as you can see, sometimes it's really hard to yeah, the bomb would yeah the bomb exploded, and then I have to replay again and remember. As you can remember, this the time changed. The time is went from 60 second to what? Okay, the time went from 60 second to a really low to like a really high time. The time is also random too, so it would be really hard to not every game is different, and then it the the position of this of the chest and the bomb are also random too. So as you can see, we try to apply a lot of randomness into a code. Okay, so these are the pros and cons that we got in this through this experience. So the pros is that the game works as intended. We code a lot, and then the game works is really a pleasure for us. The game folder, including the AI model, is really lightweight. It's really easy to implementing and no lagging and no delaying in anything. We learn and apply really a lot of engineering design method that we learned in this class. The cons is that it is really hard to keep track with all the object and the randomness without like object orientation programming in JavaScript. We can do this by applying like class and object, the game one class, game two class, game three class, right? And then the target, the balls, the object the these should be these can be the subclass of the big game class too. So we are really hard. We try a lot to keep track of the variable in our code. Uh, Furthermore, the game is lacking really a lot of statistic aspects, such as like graphics and then animation things. Like we try to um, insert a lot of images, but then they will overlap each other, and then it's really ugly to implement. So we try we try a lot. Uh, these are just further improvement that we got from our peer reviews. These are the idea, really good idea to like add more animation, add more images, and improve gameplay. A lot of ideas on improve gameplay, by the way. And yeah, it's really a pleasure to hear all the feedback we got. So in conclusion, these are the conclusion, and we learned a lot of things in this class. We learned how to use the engineering design process. We learned how to work together, and then we tried to merge all the three games together into a bigger system. And then yeah, we although we have a lot of to a lot of things to learn, but we still think that we learn a lot from this experience. That's it for our presentation. Thank you for listening, and really hope that we can do this game again in order to practice more and then make more products that have for real life. Thank you for listening.